Hello students, welcome to SA Unit 4 Notes Lesson 5. This is our last lesson for Unit 4 and it's on IXL C5, which is angle bisectors. So here's a little note to self. Bisect means to cut into two congruent parts. Therefore, if we have, let's say, a line segment and I want to bisect it, I have to create what's called a midpoint. So I put the midpoint right in the middle. What I do is I broke it into two congruent parts. So the midpoint is a bisector. It can be a midpoint or it can be maybe a perpendicular bisector. That's fine. Here's an example of a line that is a perpendicular bisector line, but it will break it into two congruent parts. We also have an angle bisector, which is a ray that bisects an angle. So here's an example of that. Here's an example of an angle bisector, which is this ray. Oh, I guess it doesn't want to do that. One more time. And what it did was it just broke this into two congruent parts. Okay, so those are just examples of bisectors. And in this case, so here's the question. If an angle is bisected, forming two new angles, each angle has a measure of 53. What was the measure of the original angle? Well, what we're going to have to do is just add these together because the original angle was 53 degrees and 53 degrees, which was a total of 106 degrees. Therefore, 106 is our answer. All right, so this whole thing, if I draw it in here, was 106 degrees. And it was split by an angle bisector being this ray. That ray was an angle bisector that broke it into two. All right, so now this is working backwards. Let's say you do have 20 degrees. What is left over? It says an angle is bisected, forming two new angles. If the original angle had been a measure of 20, what is each one now? Well, so we're going to do 20 divided by 2, which is 10 degrees. So each one of these is 10 and 10 because they're congruent. So the answer to this is 10 degrees. All right. Next one. After bisecting an angle, Jeffrey has two new angles, each with a measure of 16 degrees. What was the measure of the original angle? Well, again, we just do 16 plus 16, because bisecting it cut it in half. So I get 32 degrees. So each one was 16 and 16, but total, it's 32 degrees total. All right, we're making some progress already. Here, after bisecting an angle measuring 30, Link has two angles. What is the measure of each new angle? So this one's going to be 30 divided by 2, which is 15 degrees. So each one of these separately is 15 degrees, making my answer 15 degrees. And the next one, an angle measuring 47.8 degrees is bisected to form two new angles. So 47.8 divided by 2. Now this has a decimal, so you can bring up Desmos if you want. So 47.8. So 47.8 divided by 2. And it looks like it's 23.9. So the answer is 23.9 degrees. So together, 23.9 plus 23.9 equals 47.8 degrees. Okay, so that was pretty quick. Now these new ones are, can I use the angle bisector theorem Remember, we already kind of did some of that. What was a perpendicular bisector theorem? Let me bring up, let's see, IXL, we already did a little bit. We did the perpendicular bisector theorem in I8, which is kind of similar to this angle bisectors that we're going to be working with a little bit, but anyway, here we are. So it looks a little different. Here we have right angles. Here we have 89 and 89. So the answer is, can you use the angle bisector theorem to solve for U, T, V? And the answer is yes, because we have enough pieces of information. We have these angles, we have these sides, we have this shared side. It's enough information. So the answer is yes. And it would be 63 degrees. So it looks like we have one piece of congruent information here and here, another piece, and this third piece of shared information. So that's quite a bit. So the answer to that is yes. Now, can you use the angle bisector theorem to solve for AB? Let's take a look. The answer here is no, because I'm missing a critical piece of information. I would need to know, to solve for what that was light green. Okay, purple. To solve for AB, I need to know that AD is equal, what I need to know is I need to know one of these angles. So I need to know this angle or this angle. Well, I need both of them. Or I need this angle and this angle. So I need some more information to be able to prove that, because we don't know, excuse me, we don't have enough information to say, because of the angles, that they are congruent. All we know is they have one pair of congruent sides, the one that's shared, and we have one congruent set of congruent angles, which are shared, which are not shared. Okay, so the answer to this is no. This next one, can you use the angle bisector theorem? Again, we're in the same boat. It looks like I already answered this one on accident. The answer to that is no, because I don't know this angle. I don't know those, and I don't know these. So the answer to that is no, because I don't know, and I don't know this side. JK. All right. So again, this one works because you have this piece of information. They share this side. They have this and this, so they share another set of sides, which is awesome. And then they have these angles that are right angles. So those piece of information, that's definitely enough. We have a lot. We have enough to actually to use the theorem versus these other ones that we weren't able to. Okay. The next one, what is RS? So here you have enough information. You have these angles. You have this side and this side. Then you have these angles. So boom, we have enough. So this one is going to be SR or RS is 47. These have to be congruent because these are congruent, because these are congruent, and everything else, we have all of those tick marks to represent congruence here. So RS is 47, it has a length of 47. All right. This next one, we have enough. ST is going to have to be 83. The reason is because we have this shared, we have these are congruent, and then we also have those are congruent. We have enough information to say that 83 is the one side and 83 is the other side. The next one, what is the measure of angle RST? So in this case, we have QST is 43 degrees. The reason why is because this angle and this angle have to be congruent, because this angle is congruent to this angle, this side is congruent to this side, and this side is congruent to that side. So we have 43, 43, but it's asking for RST, which is the whole thing. RST is the whole thing. So RST is 86 degrees because you add them together. So 86 degrees. All right, 86 degrees. Okay, good. All right. We have, I think, one more page left. Yep, where we now have variables. So we're just going to have to solve for the variable. This shouldn't take too long. If angle RSU is congruent to angle TSU, and RU is 7Z, and TU is Z plus 30, then what is the value of Z? Well, what we do know is that this is going to be congruent to that. So 7Z equals Z plus 30. I'm going to take away Z from both sides. And I get 6Z equals 30 and divide by 6. So Z is equal to 5. We're solving for Z, which is 5. And all I did was I set them equal. Let's see if I was right. 5. What's 5 plus 30? Well, that's 35. What's 5 times 7? 35. So in that case, they're both 35. They're both equal. They're both congruent. So I did all the work there correctly. All right. The next one, we have U plus 16 is equal to 5U, because these have to be congruent. So we have take away U, we get 16 equals 4U divided by 4. So U equals 4. We can check our work. 4 times 5 is 20. 4 plus 16 is 20. So we are all good to go. All right. Next one. We have if GE equals IJ is 13. So GJ is 13. And IJ is 13. And GHJ, so GHJ is 59 degrees. What is the measure of IHJ? Well, that's going to be 59 degrees as well. And the answer to that is IHJ. This one was pretty easy. It's 59 degrees. All right. Here we are. We have this congruent, and we have the right angles congruent. And we have a shared side. So that's congruent to that one. So we have enough information. We're going to solve for EGH, but the first thing we have to do is solve for our variables. So T plus 5 T plus 5 equals 2T minus 10. So take away T. So I get 5 equals t minus 10. So plus 10. So 15 equals t. And what I want to do now is I want to put t back in. Let me evaluate t. So 15 plus 5 is 20. We get 15 times 2 is 30. 30 minus 10 is 20. And it was asking me to find EGH. EGH. So I have found by evaluating that I get the answer 20. Okay, next, and the last one. So here we have RS, we have RTS is equal to RTU. Okay. And they both equal 49 degrees. They have a shared side. They also have the congruent angles, so that's all good. So RS is 7y plus 1, and RU is 13y minus 71. And so those need to be equal before we can solve for RS, because the question is asking us to solve for RS. So I'm going to say 7y plus 1 equals 13y minus 71. I'm going to take away 7y. I get 1 equals 7, that is 16. Wait, I'm sorry, not 16. What am I talking about? 1, I don't know, I was adding or something. No. 13 minus 7 is 6y. Uh-oh, I'm frozen. Okay. So you get 6y minus 71, and add 71. And so I get 72 equals 6y divided by 6. Y is equal to 12. So to get y is equal to 12, what I need to do is solve for RS. So RS equals 7y plus 1. So RS equals 7 times 12 plus 1. So RS equals 7085. And so this answer is 85. If we're not sure, we can always check our work. We can take 12 and put it back in. 12 times 7. 12 times 7 is 84, plus 1 is 85. So I get 85 for this. And then RU, so I get 13 times 12 minus 71. So 13 times 12. 13 times 12 is 156. Wait a minute. RS is 85. So 12. Oh, and then minus 71. Sorry, I messed up. Minus 71. So 156 minus 71 is 85. And that's exactly what I get for this one, 85. So that answer is right. And that's it. So good luck on IXLC5 angle bisectors. All right, good night.